Looks like we're live. Hi, everybody. Thank you for joining us for another presentation about artificial intelligence and machine learning. We have a weekly webinar, where we discuss different topics every week, and every so often we pick a day just to focus in on machine learning and nothing industry specific. Industry specific topics that we've had so far, was finance, real estate, real estate prop tech, property technology. We talked about project lifecycle, project management. Um, so today we will discuss specifically a life cycle of developing artificial intelligence and machine learning. The topic here is just like all the other topics, very hard to cover all of it in 45 minutes. So we'll do my best to articulate as much points that is sort of like a knowledge nugget, some terminology to remember. Keep that in mind as you are developing your AI machine learning project for however many months or years you're looking to invest into developing that AI machine learning. Keep those in mind because you want to prepare early. Prepare early so that way any type of disruption or any type of inconvenience that does present itself down the road, you are prepared for it, and you know how to engage and where to step back into in order to keep the disruption to the minimum, right? There's a difference between shutting off a project for 6 days versus 6 months, or 6 hours to 6 days, right? Um, all matter of having the ducks in the row, the logistics, the hardware, the software, the people in the process, all in the row. So that way you're able to engage the right person, right technology, right hardware to solve your problems and have a successful deployment of your AI machine learning. So, without further ado, let's get into the slides. Um, but before I do, please remember this is a presentation where you're able to drop your comments, ask any questions you have. If I'm not presenting this live, you're able to ask me the questions that you have on the comment here as you're watching it later on in pre-recorded sessions, and I will get back to you as soon as I can. I try to get back within 24 hours. Sometimes, some weekends, it's not that easy to get back online and social media and respond to people. But please feel free to inbox me if you have questions. Feel free to drop a comment here and reach out to us. We will gladly respond to your questions and try to give you solutions that that you can actually have it tailored to yourself, right? So feel free to have any questions here. Feel free to drop your comments. We would love to hear about what sort of challenges you're facing and how we can be of help in that challenge. Um, so, what happens when you start your project management, right? You look at your project life cycle, and these project life cycle has gone through the grinder in order to get to the point where you are ready to get started with your project life cycle, right? And now you're bringing in more talents, more subject matter experts to help you with the project. Uh, and as you can tell, when you have a room full of people, not everybody can agree on what an AI is, right? So if you see a media hype right now these days, you see artificial intelligence being presented as the doomsday scenario, right? Based on whoever it is speaking the loudest, right? And on the other side, whoever's speaking the loudest to sell an AI product, they will tell you a whole another story, different version of that doomsday scenario with some possibilities, some of the challenges that you have to overcome, right? Anytime Google puts out a machine learning or AI presentation, or some writing or some research, um, people can pick sides. People can pick sides and say, well, this AI is about to give birth to another baby AI, and then we won't have any control over that baby AI. Those are some of the hypes that you see. Um, some there are some truths to it. However, we need to be able to understand how does that impact our project lifecycle, right? Because the AI machine learning capability that we're developing for ourselves have to serve us very well. And in order for it to serve us very well, in order for our return on investment, our return on data, we have to have a mindset where, as we chug along to this project, which might take years, if not months, but definitely will take some time, and we're able to maintain our composure to not to be distracted by information that comes to us, especially when there's a room full of people that cannot agree on what an AI is and what a machine learning is, and what are some of the components in machine learning that will, be disruptive, or disruptive in the fact that we might have to halt our project to take care of this disruption, right? Um, so AI machine learning, it has tons of applications, right? Um, the reason I mentioned machine learning and I mentioned the AI in the same word is because when you think about an AI, like I said, not everybody can agree uh, in a conversation about what an AI is, right? But everybody sort of can agree what a machine learning is, and that's why it's important that we use the right terminology and we are able to articulate our requirements to the stakeholders, decision makers, end user, developers, data engineers, and data scientists. As we articulate our requirement, we are able to address to them what it is that it is painful to us today, and how it is that we are able to um, solve that problem, take care of that pain using machine learning technology, right? So when it comes to AI, we see conversations like robots. We see the conversations like of self-driving cars. Um, we look at doomsday scenario, right? Or we just look at the fact of AI can take a prompt and turn that prompt into an answer. Simple as that, right? When you have an artificial intelligence that can take a simple prompt from you or simple statement and turn that into an actionable item, or an answer that you can actually utilize in order to move on to the next question, right? So you don't have to spend hours and months trying to solve one single question for yourself, right? An AI system can be in a spectrum of helping a robot to do its task, and AI can also be in the spectrum of taking a single question and turning that into um, an answer for you. So, as you understand what it is that you need in your project lifecycle, what should be the output, what should be the deliverable, right? We want to level set everybody's understanding of AI machine learning. Everybody has to be well aware of the fact that yes, there's AIs out there, but what we're trying to achieve here is machine learning. And if that's the case, we have to understand how machine learning works. A short introduction. COOPVA stands for Continuity of Operations Planning and Vulnerability Assessment. I'm a military veteran, so when I wrote mission orders, or of the day to have a task completed, or go out on a mission, go out on a patrol, whatever the case is, we always have a COOP. So, how do you continue our operation if there's a disruption? What are some of the vulnerabilities that we might face? How do we address those vulnerabilities? Um, as we are focusing on the mission, the end goal, what are some of the benchmarks that we have to meet, and what are some of the difficulties in meeting this benchmark, right? This is project lifecycle, and that's what we try to address as what are some of the vulnerabilities you might have, and we bring in knowledges from other industries and other projects into your project to help you make the best decisions, right? So decision science strategic advisor title has many of the implications of machine learning, but we can help you throughout decisions from current day decisions that you are making without AI, and then help you to create a roadmap and how you would be able to make better decisions using AI machine learning for your business, for your consumers. So that way your decisions are augmented by a system such as artificial intelligence and machine learning. So if you have any questions about these topics, feel free to reach out. Vulnerability assessment is the piece that will be able to articulate where it is that you want to be and how you reverse engineer all the steps in order to get to your vision for the future, and how AI, machine learning, cybersecurity, your blockchain, your ability to engage with transformation of systems, how do they map out, right? How do we map that out for your organization to be successful? So of course, this is a joke. If this was a real life, most likely you would do very little statistics. You would do very little of software development, right? You would have to spend tons of your time understanding your domain knowledge, right? Understanding your data, understand your data structure, understand and research your capabilities, right? Machine learning, you wouldn't do just some machine learning just because somebody gave you an access to a machine learning platform like TensorFlow, SageMaker, right? You wouldn't just jump into it. You would have to research and understand what is your end goal, especially when there's uh, finance involved in it, financial approval that you have to jump through, right? You have to do some research in order to write papers, in order to have other stakeholders, the decision makers, to give you that permission in order to move forward, right? So the sophistication of this life cycle is not as simple as just putting some numbers and hours on what you think will work. However, the basis of estimate that you have to provide most likely will require majority of your time spent in data structuring and data engineering and creating this pipeline in order for your engineers to do their job in training a model. And we'll get a little bit into the details of machine learning in coming slides. So, of course, mentioned statistics. So one of the ways you can think of machine learning is utilizing statistics inside of a system. And for an algorithm to understand how to, interact with data, it requires its ability to understand what is the most accurate output that a system can provide, and how much confidence does the system have to provide that output with high confidence. So high confidence and most accurate information is what we as a human will need, because AI is able to give us an answer, and we have to decide if that answer is correct or not. But the system has some accuracy built into it. Systems error is actually part of the future, right? Just like you will be able to have confidence in your AI, the AI will have to have some confidence in providing you with that answer. And the way it gets to it is through statistics. So, like, people are not interested in statistics unless that statistics can provide us with answer that is confident. As in, people will show up if it's artificial intelligence based answer versus if the statistics on the other side give us the answer, right? So it's a matter of perspective and understanding of where the answer is coming from and how confident people are for those answers, with those answers. uh, usually we will have a guest that will come in and do the presentation with me, and um, this week we are just putting out some information so that way, if you're interested, you'll be able to come back to our future presentation, and we will continue the discussion here about AI machine learning. But taking the next 10 minutes just to address some of the machine learning topics is the goal for today, right? Um, if you are able to understand machine learning, not the full spectrum of it, but at least some part of it, you want to go away with some history, right? You want to take away some of the history to say, um, okay, it's not that as challenging as it sounds, right? The machine learning is not really that inviting to many of the spectators or audience who's trying to understand how AI machine learning works. Machine learning is not that inviting because machine learning is a black box concept that is not uh, fully understood by many people because of the neural network, because of the statistics that goes in behind it, the algorithm that does all the hidden layer activities, right? But one key takeaway is that the historically speaking, machine learning has been in development for 70 some years, give or take, right? And data has been in collection for many, many years prior to that. So we have tons of data. We have tons of machine learning research. We have tons of machine learning information that we can utilize today. And the third part of the data and the machine learning is that data processing, right? How we are able to process data is what allows us to do machine learning research and development. So I want you to take that away in the very first to say, machine learning, yes, it's not that inviting. However, it is very possible as long as you understand what sort of data you need and what sort of machine learning you will have to engage with and where you will process it. If you can understand where you are able to process that information, how you will process that information, not only will you save time in the life cycle of project management, but you will also be able to engage with the right audience in order to collect feedback and survey um, the end users in deployed environment. So if you're thinking about the full project lifecycle and you have a roadmap, your roadmap has to start with, of course, a use case, which we'll talk about in the future slides. But at this point, just think about your ability to process those data. How do you process data today, and how it is that you'll process the data in coming days and months when you're engaging in model training? One other key takeaway I would say, if once you start thinking about data processing, start thinking about design thinking, start thinking of the humans that are in the picture, right? So I'm presenting in the Department of Air Force's CIO forum next week. And one of the examples that I would like to put out is to say, if you see a fighter pilot, if you see a jet that's flying through the air, think about the fighter pilot and the fighter pilot's, the human's activity inside the fighter jet, right? Start from that human, as in those human movements that is happening inside of an aircraft, inside of flying fighter jets. That's where you start, right? Start with the human. So if you're thinking of an organization and you see a building, if you see an infrastructure, all the humans that are inside the infrastructure, what are they doing? How are they doing their daily task? How are they coming in and out of that building? How are they interacting with the building, right? So move away from the um, desk and drawers and furnitures in the building. Start looking at the humans, right? And once you start looking and thinking of how the humans are behaving with those other, I guess, hardwares, right? You are able to understand where your roadmap should start. It starts with the human, the user, and that user, how do you address their concerns and their daily life activities, and how some of those daily life activities could be augmented by an AI machine learning is where you would start, right? So design thinking is based on user's need, and your user need, if you're trying to create a most viable product. As in that first proof of concept, if you want to be successful, start with the user pain points and start observing the user that you're targeting, right? So human in the loop is a very important topic when it comes to AI machine learning, and it's a broad topic, but just think of it from that perspective, as in human in the loop, and what sort of capability will these humans will need, and how they will make you successful, these humans that you will interact with, how they will make you successful because they have a buy-in from the project that you're trying to develop, right? So start the mind shift from I have data, I have machine learning, and I have data processing capability. Now I have the users who will use my product and will help me develop that product. And now I can frame a capability for a development in coming days. Before I move on, I want to check if there's any questions or comments. Okay. That. Okay. So usually I present data first in a long workshop or long webinars on Zoom or in person. Um, and then I go into neural network, the hidden layer that allows machine learning to create those output, right? Um, and then I go into machine learning. But because of time, let's just stick to machine learning, right? Um, there's some time constraints, so we're not going to go over all the slides here. But let's start with what happens once you do collect the data. What happens once you have your data ready for model training, right? So when you are about to train your data, you have to understand that these data are not intelligent yet. And what you're working to do is turn those data into intelligence, right? The data intelligence, artificial intelligence. And the way you train those data comes with the fact that whatever data you have at hand, however it is structured and it's ready for training, you would train it by identifying the fact that this data will need to learn these other data, right? One data will learn about other data, and then these data will have to be supervised, as in with lots of feedback, lots of more training, right? Until they get the concept right? As in they're able to execute what the input is correctly, so the output is actually worth releasing to the public, right? And on the other side, you have unsupervised learning, where it is that the system is so sophisticated that a system is able to actually take the data and try to teach itself what that data is and how that data will have to react to the environment. And reinforcement learning is, of course, again, gamified, right? You are able to interact with the data, and if the data gets the correct output, it will retrain itself to meet the right answer, the high score that the users will provide to the system. So what happens if you have lots of data and you are able to do machine learning and you're able to compute, right? Seems like my slide here does not have the visual that was supposed to be there. So apologies about that. It's not showing in the presentation, but it's there on the actual slide. What happens with your big data when you have lots of data at hand and you're able to train those data for the purposes of output that is actually useful for the humans, right? Say for example, like prompt chat gpt, you're able to type in a question and you're able to get answers from chat gpt, be it coding, be it a picture, be it just a simple essay or paragraph, right? It's important that we understand all these features had to go through a training first. And that training started from something very basic. So it all started with lots of data, the availability of those data. If not, even a small amount of data is fine. It's not about quantity of data, it's about the quality of data. So even if you have a small amount of quality data, you're able to start machine learning. And the machine learning journey, where it starts with true or false, right? That true or false statement will lead you to answers like, is this a muffin or is this a dog, right? But if you think about it, you cannot ask a system to identify a muffin or a dog. What you will do is say, is this a dog, yes or no, right? And if it's a dog, what's the confidence level, or what do you think the accuracy level of you identifying that dog, yes or no? If it's a no, how confident are you in that no, right? So you're looking at true positive, false positive, true negative, and false negative, right? You're able to train a system within those four quadrants to have ability to train more towards where it is that you would like it to be, right? If you would like it to say, if it's not a dog, just keep saying no, right? Keep saying no. If it's a yes, I don't care. So go with one of the quadrants and build your ability to identify using one of those quadrants. So as you can see, I'm not even going down that deep, but it gets deeper than that, right? Because if the system is able to train, after a while, you realize that system is not able to tell you the difference between a muffin and a dog or a puppy, right? As a system is able to identify what it is that identifying is based on this training, how it was trained, what were some of those decisions that was made during this training, what sort of question was the system trained on, right? Those are very important decisions you have to make as a decision maker in the project lifecycle. So this, I want to go over it quickly. We have about 3 minutes left. I want to go over it quickly. Is the fact that what you see today and what you saw 10 years ago and what you will see 10 years from now will be far different, right? Because the experience that you had with Google 10 years ago, or video services 10 years ago, or picture services 10 years ago, back in, say, 2022, right? Um, you are not able to really measure what you see today from what it used to be in the past, right? Because the scoring system will be off the chart. As in, we are in a far better environment with our laptops and our systems and hardwares in order to access information much quicker and faster, and put those information together much faster within our hardware, right? Um, Cache is what allowed us to access information quick and fast and able to display it really, really fast within our hardware, right? And Akamai systems is something that we might not be aware of, because Akamai is what allows Google and all these other giants, to the Twitter, Facebook, and all these other giants to have the capability of reaching an audience very, very fast using content delivery network, right? So as I'm going down this path of caches of content delivery network, what you need to understand is that the cache was a problem for a very long time, and until we solved that cache issues, um, you know, we came to realize what it is as a possibility, right? So the next level of possibility for AI machine learning, as you're designing and you're thinking about your project lifecycle, is not to say, how do I solve the problems that I have in my hand today with technology that I have today? You have to start thinking of what technology is coming down the pipe, and what are some of the possibilities that we're seeing, and how do I design my piece so that way I can adapt to that in coming days, right? So if you develop a project and then system changes 10 years down the road, now you have to scrap the whole project because something has changed in the next 10 years or 5 years or 2 years. Whatever the case is, you want to be adaptable to the fact, something along the line of, once the cache equation has changed and you're able to do content delivery network from your local areas where you can drive to this location, so the data is traveling faster to your device and network. You want to be able to think that way. So machine learning, if you're thinking about machine learning, the next best possibility for machine learning is to say, it will compute, the data will process itself inside of your device without ever needing internet. Right. So I want to take a pause there and just let that soak in, that your systems will be able to do machine learning inside of your laptop, if not inside of your phone, or at least somewhere in your home using IoT devices around the house without even needing internet. Because the internet is actually what's slowing down your machine learning capabilities. If your system is able to do machine learning in the device in real time without traveling outside of your home using internet, you'll be able to actually enjoy machine learning and build those capability for fast return of data, right? So I want you to start thinking about it from that perspective, because that allows you to broaden your project, but also makes you adaptable for the future changes that are coming down the pipe. I hope, if nothing, this presentation will lead you down the path of learning more about machine learning and get into adapting machine learning for whatever career path you're in or whatever business or industry you're part of. Machine learning will have to be somewhere in your portfolio in order to compete, in order to engage that future generations of users, the decision makers and stakeholders, right? So wherever you are in life right now, machine learning will definitely augment some part of your life. It does mine. I use ChatGPT nonstop. I'm using machine learning to interact with you in internet right now, right? And that interactions with machine learning and the video streaming services will change dramatically in the next couple of years. I keep saying 10, but what I really mean is to be safe and say, let me just call it a 10, but it's actually in reality more like 2 or 3, right? So if you have any questions, if you have any comments, would love to hear more about what your thoughts are, what are some of the questions you have. That way I can reach back out to you and give you the answers, right? Until then, next time, next week, we'll see you here. Thank you so much for attending. I appreciate your time, and hopefully, you have learned something new and have some good takeaways to take back to your team and organization and get started on machine learning. Ciao.